Hi, everyone. Welcome for joining today's Hyperledger APAC virtual meetup on Hyperledger Besu. So, and thanks again to Hyperledger for hosting us. So my name is Edmund. I'm a solution architect here at Consensus. So next, I'm going to share my screen to quickly share with you some of the rundown on today's event. So I hope you're all seeing my screen. So next, I want to talk a little bit about the background of Consensus and the background of myself. So Consensus joined Hyperledger as a premium member last September, and along with that, we actually donated our Ethereum client written in Java. So previously, this project was known as Pantheon, and now it becomes a project called Hyperledger Besu, which is the topic of today's meetup. So Besu is the first project inside Hyperledger, which can operate on both public and private blockchain. And a little bit about Consensus. We are the world's largest blockchain engineering company, and we have over 1,000 employees across 40 different locations. My role is a solution architect, and I am under the solutions department. And so I mainly help in building production-ready blockchain solutions for clients of all sizes, whether it's enterprises or startup, particularly leveraging Ethereum blockchain technologies such as Hyperledger Besu. And so we have done work on the public blockchain as well as a private blockchain consortium network, as well as smart contract related, such as development as well as auditing. So if you're interested in this space, I would love to speak with you after this presentation. So this is a quick summary of some of the work which we have done here at Consensus. So in the financial service space, we have worked with a number of banks such as Santander, BNP Paribas, Union Bank, as well as exchanges such as SGX and ElectricShare, which is a project backed by Euronext, and a number of central banks such as MAS and South Africa Reserve Bank. Other than financial service, supply chain is an area which we have done quite a lot projects in, and we work with companies in different industries such as pharmaceutical like GSK, commodity Shell, and consumer good like P&G. We have also done work on self-sovereign identity as well as strategy work with European Commissions and the Smart City of Dubai and China government. So before we go to today's presentations, I would like to use this time to promote the next webinar, which we will have next Wednesday. And the topic is on Hyperledger Besu, Ethereum, and the futures of enterprise blockchain. And we are very excited to have Brian Bernadoff, which is the executive director of Hyperledger, and Joseph Lubin, who is the co-founder of Ethereum and co-founder of Consensus, to speak on this in a very Asia-friendly time zone. So what I'm going to do next is, if you're interested, I am going to share the registration link in the chat. So if you're interested, please register, and we look forward to seeing you in that webinar too. So in the next slide, we will, before we kick off, I just want to run a little bit on the logistic. So we are very pleased to have two maintainers of Hyperledger Besu, Rob Dawson and Joshua Fernandez, who are the product lead and protocol engineers at Pegasus, to talk with us on Hyperledger Besu. And for everyone who has questions when they are presenting, please feel free to use the Q&A function in Zoom. So what we are going to do is I will, in each of the slides, I will try to gather the question and we try to clear your question as we go along in the presentation. And towards the end, we also have a Q&A sections opening up the floor. So for any outstanding question left behind. So so with that, I think that's it on me. So next, I would like to introduce Rob, who will start the presentation.
Thanks so much, Edmund. I'm going to start sharing my screen, and the slide will look very familiar to the one that you just saw before, which I'm sharing now. Okay, so I'm going to be talking to you about Hyperledger Besu. Hyperledger Besu and Pegasus Plus are products that we in the Pegasus group, the protocol engineering part of Consensus, have produced. Hyperledger Besu, you'll know as a part of the Hyperledger project, you'll know, beginning to know it hopefully more and more. It'll be a name that you will hear more and more. The Pegasus group, the Consensus, we made it available and it first became a part of the Hyperledger group last year, and very recently moved across to being an active status. The actual code base, as Edmund was saying, comes from work that we've been doing. It's almost first was made live and announced at the main sort of Ethereum conference, DevCon, in just almost 2 years ago, and it's I guess a great sort of Ethereum enterprise-focused Ethereum client. So the Pegasus group, we are focused on enterprise, which is an important part of our sort of mix of Ethereum for enterprise is how we think about ourselves as an organization. And that maps to two ways. It maps to enterprise use cases of the mainnet, of the public network that's available for Ethereum, and also very much enterprise for private and consortium chains. So those two areas we think are very important for enterprise. We see both traditional enterprise organizations, so the large investment banks and organizations that Edwin was talking about, and also some of the more sort of modern startup type companies. Maybe not modern isn't the right word, but more revolutionary, I guess, startup companies that are using Ethereum as well. And so both of those we see as the groups that we want to support and make sure that we are producing enterprise grade software with enterprise grade vendor support that is very much a part of the Hyperledger community. Hyperledger Besu is Ethereum, and so to just sort of ground us on some of the foundational ideas here. So Ethereum being a blockchain technology, the distinctive flavor of Ethereum is that it was the first smart contract-based technology that was there. There's the Turing-complete Ethereum virtual machine, which has bytecode which gets deployed and runs on chain. Besu is the node client software. So it is the software that runs your transactions, that is responsible for taking the transactions that come in, puts them into blocks. It will execute that on hardware and will generate the shared world state that gets the view of the world. It is used for both public and private enterprise. So private enterprise being similar to something like a Hyperledger Fabric, where it's a organization or group of organizations that are working together. They will have permissions that control who can get access to the chain and to the information. Public being very much that distinctive with the Ethereum in this space, that it's available for anyone to be able to connect into. So it's that distributed peer-to-peer type system that's sitting there. That is the introduction, the bird's eye view of Ethereum and Besu.
So Rob, so there's a question in regard on the Q&A in regard to the Ethereum So the question is, does it have an Ethereum node and the client, or the client? Maybe can you talk a little bit about like what it means to be like a node client?
Yep. So the node client, it's one bit of software, and so I think the idea of node and client starts to get a bit fiddly in some of these peer-to-peer type systems, and so client often is that idea that it's the server software that's running there. And so the node client is what you'd think of more in terms of server software. Independently, you'll have the ability to connect into that over JSON RPC. So sending in HTTP type requests in your client software application, which might be a browser-based, it might be a Java application, a Node.js type application, whatever language you want to use that has the ability to send HTTP type messages into the underlying Besu node software.
And there's also a follow-up question: is there the notion of certificate authority for Private Enterprise? Maybe like you could touch on this, or we can. I think we can touch on some of this like later.
Yeah, we'll touch on it later, and Edmund, if you can remind me if we've missed it when we get towards the end, that would be perfect.
Sure.
Okay, so Besu, some of the really high-level sort of features and what it looks like as an Ethereum client. The first is that the underlying technology that it was developed in is Java. To users of the software, this hopefully is not something that you are exposed to too strongly, apart from the fact that you need to have a JVM on your machine. We've chosen Java as an implementation technology to make it enterprise friendly. We know that enterprises have Java running on hardware, that it's familiar, and on their virtual machines, that it's there's a well-known tuning and performance monitoring of Java systems, and so we're able to work in with that and ensure that it's a familiar technology for people to be working with. It's open source, and it's got a permissive Apache 2 license, which is actually an important part before becoming a part of the Hyperledger community. As I was mentioning before, it works on both public and permissioned chains. And so we'll touch more on what this sort of means. The public chain for Ethereum is this idea of a mainnet where it starts to be more like the public internet in your sort of thinking about it, whereas maybe the permissioned is kind of more like the intranets or sort of internal networks that you'll sort of have floating around. We provide support for on-chain and off-chain permissioning. I'll touch on this later. On-chain and off-chain privacy, again, things that I'll be talking about. And we have some really great tooling around deployment and monitoring, which Joshua will give us a demo of some of the deployment sort of features later on. And so I will keep going through just a little bit longer. So the architecture of Besu and the architecture of a software that uses and interacts with Besu. So as a developer that wants to use this technology, you would be building your client software as it's got here some sort of DApp. The people call it distributed application, or just think about it as like application software that's interacting with the Ethereum network. In your software there, you'll have some sort of client libraries. So there's actually well-supported client libraries in many popular languages already. So Go, Java, JavaScript, Ruby, all have Ethereum client libraries for interacting with the Ethereum server software or an Ethereum network. Those your client software that you're writing will then send HTTP requests over either your private network or over the internet to your underlying client software. Those requests will then be processed at the JSON RPC layer that we've got sitting here. From that, the Pegasus and the Ethereum client will take that request, that transaction maybe that's coming into the system. It will, if it's a transaction that's coming in, it'll put it into the Ethereum core transaction pool. The Ethereum software will then take responsibility for taking that transaction, synchronizing that with the rest of the network, using our networking stack to send it out to the other Ethereum blockchain clients that are a part of your network, and adding it to their transaction pool. Within a Ethereum network, you'll be running either using a proof of authority type system. So you'll have some sort of consensus mechanism, I guess, for producing blocks in the blockchain. And so the way that those blocks will be produced is either there's having some sort of consensus mechanism around the production of those blocks. So there's either a proof of work type system, similar to the original Bitcoin consensus sort of mechanism that is there. And then there's within Hyperledger Besu, there's two different proof of authority type approaches that can be used. So one is the clique consensus mechanism, and the second, which is the one that we recommend using, is if you're using a proof of authority system. So I'll spend time talking about this later on, is IBFT2. So the IBFT2 is a Byzantine fault-tolerant consensus mechanism, which means that there will be a pool of validators that you'll have that will be sort of around there producing those blocks. That pool of validators will need to have a 2/3 +1 majority of those validators agreeing to produce a block. So that's kind of how things sort of happen at this really high kind of level within Ethereum and within Besu. When you have a block that gets produced, as a part of that block being processed, there'll be a transaction processor, which will take every transaction that's in the block. As we were saying before, these transactions are able to be more than just simple value transfer, as was originally in Bitcoin. They can actually include executable code as a part of that. Within Ethereum, the way that executable code is done is it's using the Ethereum virtual machine bytecode. And so there's a programming language, two main programming languages which you can use to create this. The main is Solidity, which is kind of I guess a JavaScript-like language. And then the second that is available for this at the moment is Viper, which is more sort of Python-based. And so these sort of languages and things that you're using to create these transactions get compiled and converted into the bytecode, which is then executed by the Ethereum virtual machine. Within these blocks that get created and executed, they will update a world state. And so this is the shared kind of state that you see across the chain, and where you start to see what actually the current state of affairs is. And so the world state can always be reached and regenerated by replaying all of the transactions in the chain. But it's actually, you'll find that clients will all store the world state to make it efficient to access the information about the current state. That's the bird's eye view of our architecture.
So Rob, maybe I think we can take these two questions, which is quite related to this slide. So maybe the last one. So is there any plan to implement Besu in other languages like Rust, Go, JavaScript?
So I think the underlying client software itself will remain in Java. There's already the client libraries for interacting with it, which exist in Rust, Go, and JavaScript and other languages. Okay, cool.
And maybe this one, can I integrate Hyperledger and Ethereum mainnet with this? I mean, maybe I can try to take this one. I think Besu is the integration between Hyperledger and Ethereum mainnet. Besu is the project, then the first project within Hyperledger that can operate on Ethereum mainnet.
That's right. And I think the other aspect of this that maybe was a part of this is Hyperledger Fabric. And so there's currently some layer 2. So if we think about the underlying blockchain protocol as a layer 1, and then things that you build on top of it as layer 2. There's currently a number of different layer 2 type projects which are looking to provide ways of having these 2 different blockchain solutions of Hyperledger Fabric and Ethereum interacting together.
Cool. So maybe, so there's one more new question. Does Besu support RAF? So as a consensus algorithm, does it support interoperability?
Yep, so it does not currently support Raft as a POA consensus mechanism. We've looked at it, the Byzantine fault tolerant sort of properties we thought were very important when implementing our consensus mechanism. And so our IBFT2 is the one that we have as an initial sort of POA type mechanism. We're very open to contributions to the project to help it support other consensus mechanisms. And so if there was someone that was able to either contribute or sponsor the development of a Raft-based approach, we would be very open to including that in our code base.
Okay. Maybe let's take this one as well. So I think this one is in the chat. So let me recap it. Does it contain peer channel orderers as Hyperledger Fabric does? So what is it on a comparison? Yeah.
Yeah. So I'll touch on some of these as we go forward. I think so I guess the key things that are there, so a channel, when you hear me say privacy group, that starts to be very similar to the Hyperledger Fabric channel. The idea of an orderer within Hyperledger Fabric, the closest sort of alignment is around the idea of a validator inside of Hyperledger Besu. From the conversations that I've had with some former Hyperledger Fabric developers, those are kind of the alignment points that I've had very closely with that. We'll get back to you around the idea of peers and how they fit into the architecture and get a better answer to that than I can give sort of on the spot right here.
Thank you, Rob. So let me suggest maybe move on to the next slide. So we see still some question coming, but let's move on because I want to make sure that within this 1.5 hours we can cover all the slides and the demo. So thank you everyone.
Yep. Okay, so public chain. So I think this is one of our very strong distinctives within Hyperledger Besu is that we are very much public chain as one of our key sort of targets, and we will make sure that, and we are very committed to the long-term support of the Ethereum public chain, as well as support for the enterprise Ethereum sort of enterprise permissioned networks as well. And so what that means for us is that I think one way that I've heard about the thinking about the Ethereum public chain is that it's the really large, long-running test network for enterprise Ethereum. And so when you think about it, when people talk about what are the volumes of transactions that you support, is your software going to scale? I think that the public Ethereum and the Ethereum mainnet shows just the volumes of transactions that Besu sort of runs well with. And so some of the key sort of things around that underlying Ethereum protocol, which I've touched on from that architecture slide, there's the Ethereum virtual machine, which is the execution environment for transactions. There's the storage for how the data gets persisted, so that world state that I touched on. There's the dev P2P protocol for doing the peer-to-peer networking with the other nodes. And then there's the JSON RPC APIs for application developers to interact with the blockchain. And I'll keep going through just a little bit, and then we can sort of move back as needed. So we talked about the public chain. Then there's also the enterprise Ethereum, which is Ethereum for private chains. And so there's a group, the Enterprise Ethereum Alliance, which is specifying a layering on top of the public mainnet Ethereum to work well for consortiums and private commission chains. Within that, they talk about the idea of 3 Ps. And so they use the 3 Ps as a nice way of alliteration and for helping us to think about and remembering what makes Enterprise Ethereum Enterprise Ethereum. The ideas that sit in with that are privacy, so being able to have private transactions. I'll definitely be diving into the details of what that means for Hyperledger Besu. Permissioning, so being able to control which nodes can connect into that peer-to-peer network and which accounts can submit transactions into the network. And the third P is performance, where performance actually often sort of translates to custom consensus mechanism. So I'm going to touch on each of these 3 Ps now, and then that will probably be a good spot for us to pause for questions after I get through these next couple of slides. So our privacy. So within Hyperledger Besu, I think there's 2 sort of ideas that we have around privacy that I want to highlight. So the first is we think that there's no one-size-fits-all privacy solution. And so there's a number of different privacy approaches which get talked about and used on Ethereum. And so there's things like the zero-knowledge type technologies, advanced cryptographic libraries for using things on-chain. And then there's an idea around not keeping your encrypted data on the public-facing sort of chain, public being either the public-wide Ethereum mainnet, or public being within your consortium, the state that the list of transactions that everyone can see. And so within Besu, we have an extension, Orion. Orion is a tool for having these private transactions that limit the actual transaction. The information is only ever sent to the participants in the private transaction. So this starts to be very similar to Hyperledger channels within Hyperledger Fabric. So Fabric channels start to map into these sort of private transactions that get sent. And they get sent to this idea of a privacy group. And so the first thing that you'll do is you'll create a privacy group. Creating a privacy group is a very cheap operation and just a straight sort of JSON RPC request that is not an expensive overhead operation to perform. Creating privacy groups is something that we expect people to easily and regularly be doing in a consortium. It then will, when you submit a transaction, it will be given off to the Orion node to be able to distribute around to the participants in that, or the members of that privacy group. They will then keep their own sort of private state, which they'll keep in sync between the members. What will be written to the public state is a hash of the transaction. And so you'll have this non-repudiation record of the transactions written to the public sort of state for people to be able to see. That information then is available on the public sort of shared ledger for people to see that there have been transactions. There are techniques made available to obfuscate the originator of that transaction so that you're not able to track that information. And so this gives a very strong repudiation, and also means that the public chain starts to act like an ordering service in like a Hyperledger Fabric kind of sense. And so it'll be the responsibility of the validators to be ordering the transactions. They will order the hash of that transaction, which will act as the way for being able to get that transaction ordering happening.
So there's one question in particular, related to this slide. Is the Orion node part of Besu?
So Orion is an independent open source project. It's a library that's included with Besu. It's also Apache 2 licensed, and it sits as a separate component. There's Yeah, there's a room for it coming across to Hyperledger. We expect that as Besu matures, the private transaction manager that it uses, we would expect it to move across to Hyperledger. There's potential some transition that might happen around that, and so we want to make sure that there's a clear strategy with that technology moving forward.
Cool, thank you.
Our next area to talk about is permissioning. So permissioning, as I was saying, it's the controlling that mix of which networks, which nodes, which client software elements, so which servers running virtual machines running Besu are able to connect into the network. And so there's that idea that we restrict those network connections to be able to be limited to those nodes in a whitelist. Then there's also the ability to control the accounts that are able to submit transactions in. And apologies, I just moved to black screen there for a second. The other area that we want to highlight with our permissioning, I mentioned there whitelist. So we have a extensive sort of models around that and governance models and the ability to support things like a role-based access control, doing governance around it. A lot of these things are very strongly in our roadmap for the future, and we would love to talk to people about how they would like to see permissioning working. When we talk about the account permissioning, so it's very much around, so the two aspects, just touch on them briefly again. So the node permissioning is controlling which nodes can connect into the network. The account permissioning is controlling the transactions that get submitted into the network. Is kind of the two ways that I think about this. And so it gives that ability to blacklist, to suspend accounts, to control what's happening on that account level. The next area then is consensus protocols. And so as I touched on before, there's three sort of main consensus protocols that we have implementations of. So the SHASH proof of work consensus mechanism. So this is the consensus protocol of the main Ethereum network. It's also implemented on the public testnet, Robston, and it's a proof of work based system, which means that it has the same sort of properties that made into that. Then there's the two sort of proof of authority systems listed here. So we have CLEAP, which is a fast sort of protocol that has high fault tolerance but does not quite offer immediate finality. And then there's the IBFT2, which is actually coming from that same CLEAP kind of family and heritage, but has been updated to be suitable for enterprise use cases in a private network. So one of the sort of flagship properties of IBFT2 is that it offers immediate transaction finality. So with this and with everything that we're talking about here, I'm sort of doing a brush over of very quickly over a lot of big features. We will share later on. There's been a large number of webinars and videos made and presentations made about all of these different features. And so we would encourage you to dive in or to reach out to us, to either Edmund, Joshua, or myself around this information to help process it as well.
Cool, thank you, Rob. I think probably it's a good time to take some of this question, in particular around the areas of private blockchain. So I think the number one questions which we get a lot is, so what are the key differences between Hyperledger Besu and Quorum?
Yep, so I think we've touched on some of these already, but I haven't sort of put up a matrix which shows the differences. So I think some of the keys that are there, so the IBFT2 consensus protocol is based on the IBFT protocol in Quorum. There are some additional enhancements that have been made to the safety and liveness of the protocol to make sure that it works, has better properties and fixes some edge cases that are there with the protocol. And so that's our first sort of starting point. The privacy group and the privacy functionality that we have in Besu, so is again learning from the way that Quorum has done it, but the idea of these privacy groups, where you can also then add and remove members from a privacy group, and they will be able to get the historical state information, is another sort of key difference that's there. Another area that's different is the license. And so Quorum is an LGPL sort of based software. It's based off of a fork of Geth. And so us being Apache 2 based is sort of means it can be easier for some organizations to work with. And a final area to sort of highlight there, and I don't want to spend time saying bad things about Quorum, just wanting to highlight some of the differences that are there. But a final sort of area that we think is important is Quorum is a fork of Geth, of the Go Ethereum sort of client. The work of maintaining that fork and rebasing their changes on top of Go Ethereum is non-trivial. And so this is one of the sort of key things that I saw when I first started working at Consensus, was actually looking at Quorum and whether it would be something that a small group would sort of want to be supporting. Our advice was, and which was taken up, was that that having this effort to have a new client would be a better path to be following.
Cool, thank you. So next set of questions is actually around, there are quite a number of questions around permissioning. So what I'm going to do is I'm going to just recap all the questions here, and then you can sort of address it in one go. So there's one question about how is on-chain, off-chain permissioning being maintained? Second question is how can role-based permissioning can be done using a platform with regards to permission to execute a method on smart contract. And the last one is how is client identity validated given Besu is capable of suspending account. So maybe you can touch on a little bit on the questions around how more details on how permissioning is being done in Besu.
Sure. Yep. So the on-chain permissioning is a smart contract-based approach. The configuration for the permissioning is stored in a smart contract, and so that is then just by the nature of the chain kept in sync with all the nodes in the chain. The off-chain permissioning is done on I'll say server or node by node basis. Each node will maintain its own whitelist and sort of permissioning file for the different nodes that can connect to it and the different accounts that will connect to it. And so what you would see in this sort of space is perhaps you might be running a consortium across a different group of different organizations, maybe if we say 4 different banks. One of those banks might want to have within its nodes have a smaller whitelist of, so within the 4 organizations, you might have a whitelist of all the different accounts that are able to submit transactions. And that would be shared. You would probably store that on-chain because it would be shared across everyone. And then within the individual organizations, the individual banks, they might have their own smaller whitelist, which limits the number of the people within there that they would actually take transactions from. And when I say people, it would be the accounts, which might actually be more sort of application level accounts. But that sort of is where the sort of use cases and things around those on-chain and off-chain type permissioning fit in. When we look at the, so looking through the other areas of those, to suspend an account, the way we would think about it is removing an account from a whitelist would be the sort of leading way to do that. and being able to have that available there. And similarly, sort of that blacklisting of broken contracts, so that similar sort of approach. The permission to execute a method. So we, as a general rule, would encourage that to be done in the smart contract itself, and to have some sort of controls in the smart contract around that method level permissions. That said, if you had a system where you wanted it to be enforced at a protocol layer, the smart contract based permissioning approach, so the on-chain permissioning that we've got, is a flexible model. We've got it well specified as a set of enforcement interfaces which are used, and so you could provide a different implementation of that security approach and use that to do permissions around executing of specific methods, if that's the sort of level of system that you would want.
Thank you, Rob. So we cover on questions on around privacy and now permissions. Maybe let's answer one question on performance, and then we move on to the further part. So is there any plan to support benchmarking test platform like Hyperledger Calibra in Besu? Maybe you can quickly also comment on the performance in regard to some of the consensus algorithm you touch on.
Yep. So I'll give a good answer to the first part, probably not as good to the second part. And I'm really looking over my overview of slides. I know in the agenda we talked about having a discussion about Caliper. So it's good that this question has come in, because I neglected to put a slide in talking about Hyperledger Caliper. We are definitely working with the Caliper project. So we use Caliper for our benchmarking, and it's used extensively by us to produce initially some simple transaction per second numbers, and we're doing some more sophisticated benchmarking as well. And I'll touch upon the actual use case and project where we're doing a lot of benchmarking work as well. So we treat that Caliper as a first-pass citizen. We are working closely and contributing pull requests against the Caliper project to ensure that it supports Besu well. And I expect, if it's not already public, we will have public sort of benchmark information available shortly around how to run the benchmarks yourself. In terms of transaction throughput, at the moment on a IBFT-based network with around the sort of 4 validators, so the sort of small number of validators that provide IBFT fault tolerance, we're seeing around the 200 transactions per second as a conservative number. That number is being hit by a limit of just the way that Caliper is currently running the submitting transactions to Ethereum, and also some of the software kind of quirks around our software around Besu. This is something that we're actively working on to improve both the performance benchmarks and the underlying software at the moment. So we have active work from the Hyperledger community and the Besu sort of developer community, and the Pegasus group in particular are working very hard on making sure that we have good performance there.
Thank you, Rob. Yeah, let's move forward. Yeah.
Okay. One of the other areas that we want to sort of highlight around it. So I talked a lot about the JSON RPC APIs. So these are the traditional sort of well standardized ways of being able to interact with Ethereum. It works as sort of HTTP host requests to an endpoint. The other thing that we like to highlight within Besu is the support for GraphQL. And so GraphQL is a standard web sort of standard for querying data in particular. there's a great ecosystem of tools and interfaces for visualizing, adjusting, and working with your queries, such as GraphQL. We within Hyperledger Besu support GraphQL as a first-class citizen and way of interacting with the client, and have an implementation of, there's a EAP. So EAP is the Ethereum Improvement Project proposal, sorry, Ethereum Improvement Proposal. So EAPs are the way that the core sort of protocol is improved and enhanced. So there's a well-specified way of using GraphQL with Ethereum, which is done in the EIP 1767. Within Hyperledger Besu, we implement and conform to that interface. So starting to look a little bit at about moving towards production. One of the key things that we think is very important with an enterprise software is monitoring and being able to look at your node and the network health and performance. And so the other part of this is being enterprise sort of software. You don't want to reinvent the wheel and add in another tool to your monitoring stack and your health. So we have done this initially with Prometheus and Grafana. We also, and I think Josh will talk about this, touch on this briefly, but have support for the ELK kind of stack is something that Josh has really been driving and making sure that we get integrated in well. So this monitoring, I've got a snapshot here showing you kind of how it might look. When Joshua does the demo, he will run through this in a live system. I've got a couple more quick slides to go through. One of the other areas that we think is, and so around this monitoring, I think definitely after Josh does the demo is the right time to look into the details there. I will quickly brush through some slides now and give us an opportunity for some more questions. So our plugin framework is an important part of our software. So Besu is designed to be modular and extendable software. To support that, we built out a plugin API. I don't think there's too much magic here. It sort of makes sense. There's an API. It has a life cycle and exposes some of the underlying services, gives you the ability to add in your own hooks to do things in different ways. So we actually, within our plugin framework, it's something that Pegasus uses to produce its enterprise version of Besu, or the commercial sort of offering and supported version. So the idea of these plugins is something that the Hyperledger Besu sort of development community takes very seriously. The Pegasus team, which is one of the sort of leading contributors, very, very much takes seriously and wants to make sure that it works well, because it's how our commercial product is built on top of that. We think that and also we've seen a number of other use cases where people are looking at building their own plugins more and more to be able to do custom things with the underlying client. These plugins currently are all very much Java based. There's some talk about having a more and will run in process with the main sort of Besu client software. There's some thinking around how to do this as a separate service and hooking out to microservices to do that. That's potential for the future. But for today, the plugin framework is very much around the thing sitting here. So the key implementations that we've seen in Pegasus Plus are encrypted storage. So encrypting that world state database when it's stored on disk. We use event streaming, so making the underlying events that are inside the system, pushing them out to Kafka or sort of those sort of message broker systems, so that you can rather than polling the clients for changes over the JSON RPC or subscribing in via a WebSocket, you're able to subscribe to a queue over Kafka and be able to more reliably see those information. And then we have some advanced monitoring that we make available as well. So I think I have touched over these 3 slides. I'm just going to flip through them very quickly and touch here. And it's probably a good point to pause for questions before I talk about contributing.
Sure. So I think one question is, so one question I find is, okay, how do they get started? What are the use cases? Like, what would you recommend to get started on Besu?
Yep. So I think there's the 2 different directions for getting started. So if you're a developer and you're sort of wanting to get started with actually contributing to the project, we're on GitHub. There's a good first issue and help wanted tags. So we'll share these slides later on. So the links take you to those queries. We have some excellent documentation around the software to help you get started. We're on the Hyperledger, standards for the Hyperledger projects. We're on Rocket Chat. And so there's a Besu and Besu contributors channel. There's lots of people that are the maintainers and developers are available on those channels for you to interact with.
Cool. There's one question on the integrations between Hyperledger Explorer to Besu. So maybe you can touch on a little bit on like Besu, what is the sort of web interface that is available?
Yep. So there's not yet an integration for Explorer into Besu. I think the Besu sort of community would love to see that happen, and would love to collaborate with the Explorer team to help make that work. But that's not something that's been done to date.
Cool.
Yep.
So
and I guess in terms of contributing, just let me do one more, and then we can move on. So the other thing that's really valuable is the contributor calls that are listed there. So we have, I guess, within the maintainers of Besu, there's a large number that are actually based out of Australia. And so that forces a lot of the work being done to be done in APAC friendly time. And so you'll see that there's calls are run every 2 weeks on an alternating schedule between APAC friendly times, and then there's sort of a European and United States sort of friendly time. And so you can see those times there.
Cool. Thank you, Rob. So, I just maybe I'm going to ask a set of questions, which is summarized on some of this question, and then we move on to the next stage. Which this set of questions is around how does Hyperledger Besu compare or integrate with other Hyperledger projects. So a big area is how would it compare Hyperledger Besu with Hyperledger Fabric? So there's people asking, okay, why would you use some Fabric, or like what domain would you recommend to use Fabric or Besu, or is there any interoperability around Fabric? So that's one question. Second question is Hyperledger Besu leveraging Hyperledger Aries and Ursus as the library? So maybe you can take this too.
Yep. So at the moment we're not using Aries as a library. The sort of execution and environments sort of, I guess a lot of it predates its inclusion into the Hyperledger sort of foundation and the Hyperledger organization. And so I think there's room for sort of changing different implementations of things as we move forward. In terms of interop and working with Fabric, so I think that we very much see that as a layer 2 sort of piece. At the moment, the direct different client-to-client integration is done at that higher layer in the stack rather than at the actual low-level protocol. In terms of Besu versus Fabric, I think that the Ethereum sort of story and the thing that you get from Besu is that public sort of mainnet support, the interop with other networks and other Ethereum networks. A lot of this at the moment is still a little bit aspirational, and it's kind of building software now that is going to work in the future sort of world that we're going to see. And I think that's the key sort of thing around that Besu sort of spot is, particularly on some of maybe when you think about a private permission chain, maybe there's elements where Fabric is still ahead in some of those specific use cases. I think Besu and Enterprise Ethereum are very strong, compelling options to consider for any enterprise network. But I think particularly if you're thinking about how you might want to interact with the public sort of chain, if you're thinking about the scalability, the future-proofing of your work, I think that Ethereum provides a great platform to do that on. Enterprise Ethereum is a way of getting the consortium and the privacy and permissioning sort of properties that you need for now. And Besu sort of offers both of those. So I'm an Ethereum fan, and so probably not giving the most unbiased answer to that question, but that's the answer that I have.
Cool, thank you. So so let's move forward, and at the end we'll have a Q&A section. So let's cover the remaining questions later. Thank you, Rob.
Sure. So we're going to talk now about deployment and how to get things running well. And this will touch, I think, on some of the how do you get started using Besu. And so we offer a large number of scripts to help enable getting your networks going in a production-ready way. So Ansible, Docker, Kubernetes, Terraform, we're on AWS, Azure, in the Azure marketplace. There's a huge number of examples that are available for it. So we provide the automation and tools to help make that easy to do. Josh is going to get into the details of this. And so our first spot that we'll talk about is kind of the getting started. And so I will, our sort of sample networks that we have available. And so I'm going to stop sharing, and I'm going to keep talking for just a moment while Joshua gets his screen being shared. And so I guess these sample networks that we start to see are available and easy for us to use. And you can see Joshua's showing his screen with that being through a Grafana dashboard, talking into some networks. I'll hand over to you, Josh.
Cool, thank you, Rob. Good evening, everyone. Right, so before I jump into the sample networks, I'll quickly touch on the dashboard itself and why we recommend using this. So this is one of the key things that we recommend people start deploying right from when they're deploying the network itself. Reason being, it gives you a lot of insights into how your network is performing as a whole, but also how each individual node is performing. So you get early warning signs of maybe a node's going down, or you're running out of disk space, or some weird error, and maybe some other process is going wrong and CPU has spiked. So I'll touch on this first. So right up top, this is something very near and dear to my heart. I'd like to have a clean overview of all the nodes that we have. So I've spun up a few in the last week. All these are public nodes on public networks, sorry. So there's a few mainnet, there's Ropsten, Rinkeby, and a couple on Goalie. Now what you can see straight off the bat is the chain height of each node as well as the target chain height. And as it gets to the target chain height, this should be 0 eventually. Things like block number, you'll eventually see, like for the Goalie and the Rinkeby ones, when they eventually come back to normal. We generally don't like seeing these above 15 seconds, give or take. And you can alert on every single thing over here. So when you have a new node come up on a public network, by default, they generally use fast sync. So on this dashboard, any nodes that come up, automatically you get a view of what's going on in the fast sync. So you can see these two mainnet nodes aren't far from reaching their heads, but there's one in here that's quite broken, and it works very well for this demo. So the other things that you can see are block time itself. So if this gets too high, you can trigger an alert from here. The same for blocks behind. You generally don't want to see any nodes going back. So this expression over here is because of the node that we've broken in here. So this gives you an overview of all the CPUs. So you can again put an alert across the entire lot. And if anything goes over a certain threshold, you've got an alert that comes to you. And you can set up early warning systems. You don't have to wait until things go really bad. Garbage collection is another key thing. So if we generally like to see all nodes hovering around about 0 to maybe 5%. In this case, this is a very good example of something that's gone really, really wrong here. So if I see a garbage collection where the graph's going like this, it's very bad. And straight away, I know I can jump into the box and I can have a look and see what's going on. Similar process for memory. Now, just to get going, quick start. The main thing that we'll touch on today here is the quick start or the sample networks repo. So this is a very quick way of getting you up and running on your platform of choice. So that we do Linux, Mac, as well as Windows. And you've got, it's sort of pick a user scenario that matches your needs. So for example, if you're a dApp developer, you only may need just the blockchain and the bare minimums of monitoring. If you're a sysadmin, you may care about logs and so on and so forth. So I'll do a demo on this in a few seconds. But one key thing I'll touch on is every example that you see over here, you've got setups of how you can start things up. And say, for example, if you're a dApp developer, you can spin everything else up here and you only know that your dApp just replaces this orange box and you're good to go. And the last thing that we've done to make things really easy for people to adopt and get used to things is we've got video tutorials scattered in between. So you can see live examples of how things work, and there, you click on them, they link back here. So to answer some of the questions that we had on permissioning, how you can allow or disallow nodes, there's a good example in here where we've got a dApp that comes up and you can, on the fly, disallow nodes. The same for privacy as well as for dApps as well. So in the demo today, or at least the first one, we'll be covering this use case over here. So we've got 4 nodes on the network, one IBFT2 network, an Explorer over there, monitoring setup that I've just covered over there, and we've got logs. A recent addition that we've had to this is that we've got support for Elk natively now. So any logs that you have, as well as this dashboard, if you don't want to run Prometheus and Grafana separately in your infrastructure, you can just run native Elk, and you have the same dashboard replicated over here. So you get exactly the same things. You've got the summary of all the nodes in there, the block times, blocks behind, CPU, garbage collection, and memory. And I'll quickly jump into the logs. So for all the Besu nodes, so I can go, if I'm only interested in just the messages, for example, I'm not really interested in everything else, I can see everything over there. And because I'm running a local setup over here, you can see I've got containers over here, and I can drill down on one specific container. And so we use this to quickly see what logs are coming out of a single machine. And same if there's something going wrong, you can see this very quickly over here. So the way I've started this up is I've run this command over here. I'm not going to do this right now off the top because it takes a little while to get going. But basically, yeah, you see the 4 validators over there. There's one RPC node that comes in excess. So you make any RPC calls to it. All the code for this lives in here, and we've got documentation for it. The second example that I will quickly touch on, and then I'll move on to some of our other deployment mechanisms and tools that we offer, is the Kubernetes repo that we offer. So that's in Besu Kubernetes, where we offer, again, networks for Ethash, for Click, as well as for IBFT2, where we cater to both people that use kubectl as well as Helm. So you've got the full in-depth view of exactly what you're building. So I'll just jump into Helm quickly. So we've got setups from just basic IBFT2. We've got setups with privacy, with Ethash, as well as a full-blown consortium. So if you want, you can go down to the level of having a consortium which just has your validators in there, another namespace for just members, and another namespace for monitoring. One thing I'll add is that with all the setups, you get a clean separation of a namespace just for all the Besu nodes and things that you have, and there's another namespace for monitoring. So I'll quickly jump into that. So I've got a local Minikube setup running over here. I've got 4 nodes in here, and I can quickly jump in, check on logs, and everything's humming away quite nicely. The same dashboard is available, oops, well, this one over here. So I got 5 nodes over there, same block time, blocks behind, everything runs up nice and clean. And where is it? Sorry. And you get the whole overview of how everything works. So that particular one was the Helm IBFT2 variant. For those of y'all that are deploying this in cloud platforms, in AWS, GCP, or Azure, we've also got ingress rules. So you can have an ingress controller that routes to the Grafana dashboards as well as to the RPC nodes. So instructions are all over here. I haven't got this in this demo because I don't have enough time to cover that. So quickly, I want to touch on a couple of other things in this, is that you'll see that absolutely nothing is deployed in default. What you instead have is everything's deployed in a Besu namespace, and we've got everything down to RBACs further down here. So each validator has its own policy that you can, that it gets the keys and secrets in. And for those of you all that have AD and things like that, and you'll want to restrict users to only using a certain node or have access to certain validators, you can easily tap onto these RBAC policies and force your own add-in. And we welcome, pull requests and things like that. Happy to have anything like that. Okay, so all of these have automatic monitoring, as I've mentioned earlier. So to maintain our fleet of nodes, we heavily use a Ansible role, which provides you things like a systemd service that you can go start, stop, so on. There's support for logging, there's support for environment variables, and so on and so forth. So this is used by us pretty much in most places. We also support Terraform. So if you have AWS or Azure setups, we've got them here. So there's multi-node setups over here. There's also Kubernetes setups in each. Similar sort of thing for AWS and for Azure. And I think that's about it. So I'll hand it back to Rob now.
And so I think just a couple of things I really want to highlight with the work that we're doing around that deployment sort of piece. The first is it's very much meant to be enabling the DevOps kind of world, treating the infrastructure as service. So there might not be as many sort of fancy UIs and things around that, but it's all the tooling and things that are needed for DevOps teams, for sysadmins to really, and the SREs to really make sure that everything runs in well with the rest of the infrastructure. Following that sort of vein, that's why there's the Prometheus and the Elk sort of preference around the logging and the generation of the metrics to again fit into the tool chains that sysadmins are familiar with. And so we very much want to make sure that we're fitting in with the production ways that people will be familiar with working with their systems.
Well, thank you, Rob. So maybe we can take one question here, which is generally around this topic. So there's a question around, is the Git, which I think that's the one we show, is that open source or is it private to the tools? Maybe I think it's good for you to touch on. Okay, so for all the stuff that you show, okay, what are open source? What are some of the commercial offering? Particular, I guess the audience today, a lot of them are developers. Okay, so like what are the things which leverage open source and what are the things which require commercial support?
Yep. So the vast majority of everything that we've got is open source, and so the samples and everything that we're looking at today were all open source. Everything that's open source that we've got, we very strongly default to an Apache-based license to make it permissible and easy to work with. The only exceptions that you'll ever see on a Pegasus repo will be if it's a fork of another library. And so we've carried on with the license that was there just because that's what you have to do. So the sample networks that we're looking at there, the Kubernetes and other areas, they are all available under an Apache 2 license. the more commercial things were some of the features that I touched on earlier, which are done via plugins to Besu. So that's the advanced validator monitoring sort of functionality that I touched on very briefly, the event streaming, so the Kafka sort of integration, and database encryption at rest. So those three things require the sort of commercial license, but the rest of our software is open source, and we take our open source sort of community very, very importantly within in Pegasus. And very much this conversation that we're having today is very much around the open source Hyperledger Besu sort of project, where we will. Josh and I are both, full disclosure, part of Consensus and Pegasus, and so we come with that sort of direction. But it's very much a first-class Hyperledger project is Hyperledger Besu, which is bigger than Pegasus.
Thank you, Rob. Yeah, so I think it would be good to use the remaining 15 minutes, at least to cover the use cases, and then we can use the remaining to address outstanding questions. Thank you.
Sure. So really quickly, I guess with the things that we're talking about, I think having vendor support is a useful thing. So this is my put on my Pegasus shirt strongly and say, please do think about having the vendor support. We would love to do that. But I don't want to spend much time on that. I want to actually focus on some of the use cases. And so it's industry agnostic software. There's use cases and people working on it, banking, financial services, supply chain, and healthcare. I guess a lot of the different use cases that Edmund was putting up early on are either on and using Besu currently or on the path to using Besu. And we've had, I think, since becoming an active part of Hyperledger, an active project in Hyperledger, which is something that happened recently, it's been another sort of moment for us where we're seeing greater and greater uptake with it. Besu being active is a strong indicator that it's not tied just to Pegasus. It is a true first-class part of Hyperledger. So there's two use cases in particular that I want to touch on just now. The first is LACchain. And so LACchain is a consortium that's been set up in the Latin America and Caribbean, so LAC, and then it's a chain, so blockchain, LACchain. The purpose of LACchain is producing shared blockchain infrastructure for the region. And so they're running that, and so there's a consortium that's available for the Latin American Caribbean sort of region, which is running on Besu, using all of the features. So it's using the IBFT2, it's using permissioning to control who can connect into the network, and it's using the privacy features as well. They are currently one of the interesting things that's currently happening in LACchain is building some blockchain-based solutions to sort of track and combat the spread of coronavirus. This is something that I think very topical for everyone. Josh is sort of been working with them as well to make sure that the performance throughput and understanding the characteristics of what happens with the smart contracts that they've got there. It's a project that's in its early days, but is looking to be a very useful tool for that consortium in, I guess, helping to track and prevent the spread of coronavirus in Latin America. Another use case to highlight is Adhara. So Adhara is they partner with Pegasus. They have developed a number of solutions on top of Ethereum and Besu. The one to highlight is they've got a Token Plus product that they've deployed to the South African Stock Exchange, Zarex, to do, like it talks about here, distributed settlement system for unit trusts. And so this is built on top of Hyperledger Besu, and is running successfully in that world. Atara are using Besu as their client of choice for a number of other projects and partnerships, which we'll be able to talk about more and more in the future. It's still sort of early days with some of those other projects and things that they're working on. Those are a couple of the use cases and things to touch on there. We've got a bunch of sort of links to help you kind of get started and think about using Besu. So our documentation, which is, I think, you know, maybe I'm a little bit biased, but is excellent. It's definitely above and beyond any of the other Ethereum-based elements of documentation. It's, I think, one of the actual distinctives for us as a product. And so that's available on the Hyperledger sort of site. You can see besu.hyperledger.org. We have the sample networks and Kubernetes GitHub repos, which Joshua shared. Again, as I mentioned before, these are open source repositories that Pegasus hosts. There's the main GitHub repo, which is the Hyperledger under the Hyperledger GitHub organization, and it's the Besu repo there. And we've got a link to the wiki. Again, these slides are ones that I'll share later so that you'll be able to have access to them. Questions, and thank you so much already for all the excellent questions we've been receiving. It's been actually really, I don't get to hear everyone and see everything that you're doing, but it has been feels like a really engaged group of people, and I really appreciate that.
Cool. Thank you, Rob, and thank you, Joshua. So, so what I'm going to do now is, I know some questions we didn't quite address, but we'll sort of go for that sort of one by one with the remaining. If you have additional questions, feel free to drop in the board. So that's one question being asked pretty early in the conversation. Does Besu support Ethereum 2? Okay. Can you talk a little bit about what is Ethereum 2 and or whether it does or not, or what is Pegasus plan to support Ethereum 2?
Yep. So I think it's a good question, a big question. So Ethereum 2 is the future's kind of scalable version, ultra scalable version of Ethereum, particularly focused around getting that scalability happening on the public sort of mainnet. Trying to, I think the numbers that get talked about would be maybe 1,000-fold kind of increase in the number of transactions per second. And so there's a number of things that are being done to help add that scalability into the system. It is an active research area with ongoing research that's been done over a number of years. Some of the brightest minds in the Ethereum sort of community, in the blockchain sort of world, are doing research in there. The research and work is being done very much in the open. And so that means that we start to see a lot of the rough edges and things being fleshed out for that way earlier than you would in other sort of projects. And I say that by way of highlighting that it is still kind of early a little bit in the life cycle of Ethereum 2. One of they've broken down Ethereum 2 into a series of phases. The first phase is phase 0. The phase 0 is getting in a beacon chain. The beacon chain is going to be a initial source of randomness and being able to track the overall sharded architecture, which will be the future sort of phases that get rolled out. The beacon chain itself is initially being implemented as a thing that's separate to Besu. We are not including a beacon chain support inside of Besu in the initial sort of view of the world. as the technology and what it does is quite different to how Besu kind of works currently. The beacon chain works, the initial sort of public test networks are scheduled to be happening any day now. And then from that, there's an expectation of after about 3 months, so it's probably around July, maybe August at the moment, there will be the launch of a public mainnet for the beacon chain. That'll then follow with sort of test nets around the real sort of sharded sort of environments. The architecture and exactly how the sharding and cross-shard communications and everything happens is still being fleshed out and researched. There's a thing talking a lot about what the execution environments for each different shard will be. And so those different execution environments or what it's going to look like sort of changes and moves a little bit. It's expected that one of the leading initial execution environments will be the EVM. And so will look very much like what the current enterprise Ethereum and Ethereum looks like. And so I think there's a lot of work and research that's being done still on Ethereum 2. It's still, I think, for thinking about it in terms of enterprise use cases, right now, Ethereum 2 is the future, but we're still a little ways away from it. The expectation is that there will be a very clear transition from Besu and Ethereum and enterprise Ethereum to Ethereum 2. And how that works, I think it's too early to say exactly what that's going to look like, but I think there's strong commitments from the Besu maintenance community to make sure that transition is as seamless as possible. And I think it will be quite seamless for enterprises that start using Besu now to make sure that they are able to work well into an Ethereum 2 future.
Thank you, Rob. So
sorry, that was a long answer.
Maybe we'll take one more questions, and then you can share a little bit. Okay, if there are further questions, I hope today's event is just definitely at the beginning. So if for all the attendants here, if you have further questions, feel free to join the Rocket Chat. For myself, you can reach me on LinkedIn. If you have any further question in regard to Besu, Pegasus, consensus. So the last question maybe we take here. So any idea when the .NET Ethereum library, Ethereum, will have extension to support privacy transaction in Besu, as it already support Quorum?
It's a good question. I don't have a good answer. There you go. It's a quick one.
All right. Cool. So yeah. So I guess is the recording available? Yes, the recording will be available. So maybe I take one more question. So there's a question around can you share a little bit of the work that we have done with LVMH? So maybe I'll take this one. So particular France team is working with LVMH. So LVMH is a consumer goods manufacturer. And they have a lot of products, in particular in the area of luxury product like handbags and all this. And the work that we are doing is we are using blockchain in the supply chain area to check individual goods that are making, let's say, a handbag. And we are leveraging some of the tokens specification, in particular around what we call non-fungible token. So ERC721. Which is certain representations on a blockchain, which you can represent as a single unique asset on a blockchain, which is similar to, let's say, if you have a luxury goods. So that is a quick answer on the work that we are doing in France. Okay, so I guess yeah. So I think that's it so far. So I just want to take this chance to thanks everyone. So thank you, Rob, and thank you, Joshua, and thank you everyone for attending this meetup. Okay. Julian, are you still here?
I am. Yeah. So we'll call that a wrap. We'll
Yeah.
call that a wrap. Thank you very much, everybody. Yeah, and thank you, Edmund, Joshua, and Rob. That was a fantastic. And yes, as you said, just the beginning. So please keep in contact with this community. Take care. Cheers. Bye.
Cheers. Thank you.